Okay, I'm taking a look at question number 9 here from topic 8. This is in the exam style questions, and it's a multiple choice question, which means that you don't get a work solution for it unless you contact me, which a student has done. So let's take a look. We're asked to find what happens to this distribution here when we have both area and temperature. So this is what's called a Stefan-Boltzmann distribution. And the equation that you guys are familiar with is given here by Wien's law, where wavelength times temperature is a constant, and that constant is 2.9 times 10 to the negative 3 meters Kelvin. Okay, so the question is, what happens on this graph? Well, in order to answer that question, we need to consider some things. First, we don't need to worry about area. That area is only thrown up there to distract you. Okay, it is not part of our answer here. So if we just focus on Wien's law for a second and look at maximum wavelength, what we're going to find is that wavelength is inversely proportionate to temperature. And we already know that we are having our initial temperature, which I have given by T sub 0. Okay, so our final temperature, T sub 1, will be given by 1/2 T sub 0. So we then set up our equation based on this proportionality, and we have initial wavelength times initial temperature is equal to final wavelength times final temperature. We then slightly rearrange this and do a little bit of substitution. And what we'll find is that our final wavelength is equal to 2 times our initial wavelength. Okay? So that is the first part of solving this problem. So we then go up here and we look for peak wavelengths that are double our initial peak wavelength. So it's important that you identify that initial peak wavelength. And we can see here we have two options. Both B and D have double the peak wavelength. Okay? So, however, our intensity has decreased by half in B, and the intensity is the same in D. So then we need to think about what's happening here. We've decreased our temperature by half, right? And here you can see I have set up a Boltzmann distribution. In fact, it is exactly the Boltzmann distribution you've been studying. We haven't looked at the mathematics, but you can see them here if you're interested. But if I decrease temperature with this slider, you can see that my intensity must also decrease. Okay? So without even worrying about the math, we have now eliminated D because it has the same intensity as my initial graph. So B is the only possible option here, and that is where I would recommend leaving it. Okay? So there you go. Let me know if you have further questions. And have a great day.